Thank you for downloading this podcast from Talk Radio 702 and 567 Cape Talk. For more podcasts and more information on your number one news and talk station, please visit 702.co.za or capetalk.co.za.
Stand up for the law. Stand up for decency. Stand up for compassion. Stand up for respect. Stand up for your community. Stand up for your future. Stand up for South Africa. LeadSA.co.za. The Naked Scientist on Talk Radio 702 and 567 Cape Talk with Reedy Clubby.
27 minutes to 10 o'clock. Good morning, Chris. Nice to chat to you again.
Yeah, likewise. Hi, Reedy.
Hello there. Okay, we go straight to the lines. In fact, no. I'm inviting calls on 021-446-0567, 011-883-0702. Now, Chris, somebody has taken me to task that I'm not doing justice to the SMSs that come through. So we will start with, I know. We'll start with SMSs this week. They're very, very cross with me. They're just so many, as you know.
Oh dear.
How's this one? How does it's an SMS. It says, why does dog poo turn snow white after lying in the sun for a few days?
It's interesting because in some countries that's still true, but in others it's not. And we used to have quite a white dog poo phenomenon here in Britain. And then about 15 years ago, it suddenly disappeared, and actually magazine articles started to appear. People are saying, where has white dog poo gone? Mm-hmm. And the reason we think for this is, is it's down to calcium. And the source of calcium that used to be in dog food mostly was stuff from ground up bones and bone marrow and bits of cow and stuff that people didn't want to eat. And in the wake of the BSE, bovine spongiform encephalopathy problem, which was the mad cow disease phenomenon where there was a protein called a prion in the brains of cows, which if you eat certain bits of the cow, including brain, spinal cord and lymphoid tissue, like the spleen, then you can transmit the agent into other things. And domestic dogs and cats, big cats in zoos and that kind of thing started to get the equivalent of BSE. So they put enormous restrictions on what sorts of material can still be used in those pet food products. And I think, although this is speculation, but I think the absence of white dog poo is because of the absence of that material in some countries that were affected. Other countries where the rules weren't implemented because they didn't have a problem, mean that they still continue to use some of those sources. So I think that white colour is excess calcium and other material which has gone through the dog, hasn't been absorbed or hasn't been metabolised and is left behind in the faeces. And as they dry out and microorganisms eat the other organic bits that they can consume, it leaves behind more of the calcium type stuff, which is a white colour.
Very interesting question, I thought. Here's one from Rob. It's an SMS as well. It says, is water wet or does it only make things wet?
Well, I suppose it's a philosophical question, isn't it? I mean, water is two hydrogen molecules stuck onto an oxygen molecule, and it's a liquid, so it's a solvent, and that means it can dissolve things. So the thing that is getting dissolved, if you take some salt, for example, you're taking crystals of salt, sodium chloride, which are an ion, a mixture of ions of sodium, Na+ and Cl- ions. The water will pull those ions apart, and they will end up dissolved in the water. And so I suppose you could say that water both wets things and also is itself wet. So I think both answers are probably correct. If you think about it, dissolving salt or sitting on a surface, both are probably true. But if anyone wants to sort of argue the point with us, why don't you tweet us as @NakedScientists if you'd like to argue the alternative.
Okay. And another SMS asks, I think we've had something like this, but never mind. Is the Fukushima nuclear plant posing global threat, and why? That is from Marcel in Cresta.
Hello, Marcel. Well, what happened at Fukushima when the earthquake went off was, of course, there was no direct threat to the nuclear stations because Japan, being as it's in a geologically, seismically active area, had planned very well in creating their stations so they would be extremely robust and resilient against a ground tremor. And the stations were absolutely fine after the earthquake went off. the thing they hadn't planned for was the arrival of this enormous tsunami. And what that did was to breach the coastal defences, which weren't very big, and then flood in around the power station complex and took out the emergency generating capacity that they had to provide their electricity to run the nuclear plant. And that meant that then they couldn't pump water, they couldn't move their coolant properly, and the reactors started to overheat. And some of the reactors, unfortunately, had meltdown phenomena, whereby the fuel, which is inside the reactor, which is normally in the form of beads or rods encased in material, this got too hot, and it caused the fuel to run as a liquid out of the material in the rods and end up pooling in the bottom of the reactor. And once it's in that condition, you can no longer control the rate of the reaction very efficiently. It can either go up or down depending upon the speed of the neutrons. So you turn a stable situation that you can control into an uncontrollable one. There was some release of radioactivity, and the site remains highly radioactive. But in terms of the grand scheme of things, I think given what could have happened, the actual outcome has been relatively minor. That said, for the people that have had problems and have lost their homes and can't move back into the area, it's obviously had a major impact, and it has had a worldwide impact in a non-nuclear sense, because many countries have either decommissioned or shut down nuclear stations or commissioned very intensive investigations of their own nuclear infrastructure to make sure they're safe. So it has had a knock-on consequence, but not necessarily of the type that you might expect.
Thank you very much. And let's go straight to the lines then. Domingo in Retreat. Good morning.
Good morning.
Mm-hmm.
I would just like to ask the naked scientist, what is it? The naked scientist.
Yes.
You know that I am now 70 years old. I have seen ants a certain size, fairly big, all my life. 20 years ago, I saw in Betty's Bay, the ants were tiny little ants. And all of a sudden, I see these tiny little ants now at my home in Retreat, and there is not a sign of the bigger ants. So what has happened to the bigger ants now?
Okay.
Yes. Well, obviously I can't comment on your unique geography or your specific area, but this is certainly true that animals are a dynamic thing. Just because something has lived in one area for one period of time does not mean it will continue to live there, and changes to an area may shift the balance so that certain animals become favoured and other animals find it harder to eke out an existence and they move. And this is one of the reasons why scientists are worried about climate change, because if temperature changes significantly across the world's surface and also rainfall changes across the world's surface, which it is already doing naturally as well anyway, what happens is that areas become more or less friendly towards the existence of certain organisms, or they cause humans to change their behaviour as well. This modifies the environment and animals begin to move, and when animals move, then the things that prey on them move, and the things they prey on move, and the diseases that they carry and transmit move, and so you've got a whole shift in the ecosystem, which sort of smears and moves geographically. And it might be that with your ants, what's happened is that something has occurred locally which either has affected the temperature, affected a food source, or has enabled a new variety, there's smaller species of ants, to come in, and they have outcompeted the big ones by sheer volume of numbers. Perhaps they are stealing the food the big ones would have eaten, and as a result the big ones can't exist there anymore, so they've moved. And this has been happening for millions and millions of years on Earth, where animals encroach on and then retreat from various territories. And that's all part of life's rich tapestry. The worry is whether we're going to accelerate this process by the impact that humans have on the environment.
Let's go to Jeff in Wynberg.
Good morning, Rita and guest.
Mm-hmm.
I got an email regarding microwaves. Basically, the principle was that they took water, a jug of water, and they divided it equally, and then they boiled half in the microwave and they boiled half in a kettle, and then they did an experiment with two similar plants, and they watered the two plants with the cooled boiled water from the microwave and the kettle, and the result was that the plant that was watered from the microwave water died, and the plant that was watered from the kettle water lived. Can the naked scientist perhaps explain this?
Interesting.
Hello, Jeff. This is a very common myth conception. It's been doing the rounds on the internet for quite a while because a number of 702 listeners have sent me the pictures. You see these little sort of cress plants in pots on someone's windowsill, and then one of them wilts after a number of days. The answer is that it's a myth, and the reason that you should be very sceptical is that the numbers are absolutely tiny. You would never do an experiment where you'd have one plant with one thing on it and one plant with another thing on it, and then draw a conclusion, because just down to chance, one of the plants could have been sick and was going to die anyway. So your conclusions could be flawed. So you have to be very careful. If they'd done the experiment properly, they would have used very large numbers of plants in each treatment group for the normal water and the microwaved water, and then it would have been a fair trial, because the chances of things happening just due to chance would have been minimised compared with the very large sample size they were studying. So any good science experiment uses big numbers of participants or big numbers of study subjects. Why this should have an impact or not? Well, microwaves, the way that a microwave oven works is that you're using a form of light. Microwaves are a form of light, which go across the inside of the microwave oven in what's called a standing wave, and they make water molecules vibrate or flip backwards and forwards, because water has a plus end and a minus end because of the structure and shape of the molecule. And that vibration, when you make something vibrate, it gets hot, and that's how microwave ovens heat food, by making the water molecules in the food item vibrate and get hot. So once the microwave effect is withdrawn and taken away and the water has cooled, there should not be any long-term difference to the structure or the composition of the water over and above any effects because of heating the water. So if there was no other difference, then there shouldn't be any problem with having microwaved pot of water. So don't be taken in by this particularly prolific internet myth.
Now, there's an answer to the first caller, Chris. Anne says, hi, his large ants moved to my house.
Well, I've got the small ants in my house. I've just killed about 15 of them crawling across my worktop. We live in the countryside, and everything just helps itself to everything in my kitchen. I've set up a webcam so that I can now watch what's going on in my kitchen, because I've got basically a zoo in my house emerging. I think there's a rat that comes in. He just walks into my kitchen, just breaks in through the wall, because it's an old cottage, and so there's loads of holes in the wall, and just wanders in and nicks stuff out of the fruit bowl. And so I've set myself up with my camera so I can now see him and watch this rat. And he's very cheeky, because he comes and steals the apples and things. And there's an apple he's got at the moment, and it keeps moving around the kitchen floor because it can carry this apple, but the hole it wants to get it in to get it back out of the house again is too small for the apple. So it's slowly eating the apple around in a circle till it's small enough and it'll get it out. So I'm watching this on my camera.
Chris. Okay, let's take a break. We'll be back with more calls.
The Naked Scientist on Talk Radio 702 and 567 Cape Talk with Reedy Clubby.
And we're taking your calls 021 446 0567 011 883 0702. Beggy, you're calling us from Ga-Rankuwa. Good morning.
Ready? Ready, morning. Morning?
Yes, Beggy, go ahead, please.
Yes,
your question.
I just want to ask this question. I heard this from Jenny's show Q&A 2 years back, that there is this thing, or this concept that after a period of 100 years, the world or the planet Earth maybe, that what we are living at, it's going to change its shape. So from now backwards, it's about 100 years. I want to know from Chris, this is myth or is it real?
Okay, so does the shape of the Earth change every 100 years?
Hi, Beggy. Well, the world shape is changing all the time at a very small resolution. Mountains are growing a little tiny bit taller. The coast of America is moving further from the coast of England and Africa, roughly at the same rate that your toenails grow, actually, because the mid-ocean ridge along the middle of the Atlantic is making new seafloor, and it's pushing the two continental plates on either side away from it, so the Atlantic is getting a little bit wider every single year. So the Earth does change subtly all the time, but in terms of gross, massive shifts around, they happen on geological timescales, and that means millions of years. And if you wind the clock back to the time of the dinosaurs, then all the land masses were jammed together initially a few 100 million years ago, and you had Pangaea. Now we've got the continents all a bit more separated, and Australia stuck down there on its own, and Antarctica all stuck down on its own. Antarctica used to be linked up to Australia. It had a tropical climate and penguins that were 6 feet tall wandering around. Very different now.
All right, and from Beggy to Jill. Jill, you are calling us from Fourways. Good morning.
Hi, Reddy. I want to ask the naked scientist how corrugations occur in a dirt road. We've just come back from Makangubwe, which was wonderful, but the roads were really terrible. Not just waves in the roads, but sort of like ripples all over the dirt roads. What actually causes that?
Yeah, that's a very good point, and something I've thought of myself, because when I was driving around in the outback in Australia, I had exactly the same problem, and you think, gosh, has someone come along and made this road have these corrugations, which are almost perfect, and you have to get the grader on it to scrape them all off? And the answer is it's probably actually vehicles with dodgy shock absorbers, because what effectively happens is that the vehicle goes along and goes over a bump, and goes up a bit, comes down a bit too hard, and dislodges some material, which it then heaps up in front of the tyre, and it drives over it. And over time, you slowly push these things into a series of ripples, which I think are effectively driven by the shock-absorbing systems on cars. And so I think it's a consequence of the way the vehicles actually work and the way they damp the bumps. And so if we didn't drive down the roads, those ripples will go away. I wondered if, to start with, you were going to talk about the ripples that you see in the landscape and at the beach.
Yeah.
Because obviously when water runs across the surface, and even in clouds in the sky, when you have a jet stream of air moving in one direction and then the cold air, the warm air rising from the Earth's surface that then makes the cloud layer, you can sometimes see a series of clouds that's a sort of a ripple phenomenon. And that's a sort of similar thing where the air is going along and then tripping over the top of one mass of air and falling down into the gap afterwards, and it creates this ripple phenomenon. You see it also in geologically, where there's been enormous floods. You can see these heaps of material deposited, which then creates a little sort of turbulent area behind the heap where more material spins around and gets deposited on the next heap. So I think, but I think in the case of the road, it's the shock absorbers on vehicles.
Thank you very much, Jill. And Louis in Centurion. Good morning.
Good morning, Rudy. Good morning, Chris. Scientists theorize that the first water was deposited on the Earth by comets. If you take from the Big Bang, how was the first water formed in outer space? What process?
Hi, Louis. Well, we know for a fact that hydrogen was one of the most abundant products of the Big Bang. So when the Big Bang went off, you had this unleashing of energy, and energy was converted into matter. There was a lot of hydrogen, a little bit of helium, which is the second element in the periodic table, and then a trace of lithium, which is element number 3. The hydrogen got together in some of the first stars, and those stars, because of their sheer scale and mass, squeezed the hydrogen together so hard that it underwent fusion, and you then started fusing hydrogen to make helium, and then you could fuse helium to make bigger elements. And in these very big stars you have what's called nucleosynthesis, and this is where you squeeze progressively bigger and bigger elements together, fusing them to make more complicated elements. And some of the products of that nucleosynthesis, and also supernova explosions, when these big stars blow themselves to pieces, would have been oxygen. And so you would have had hydrogen from the Big Bang, you would have had oxygen from stars, you put the two together and you get water. And you don't just get water, actually. Out in deep space you can detect there's clouds of alcohol floating around, there's formaldehyde floating around, there are all these complicated chemicals created, actually from the chemistry that goes on in big stars. So you could think of big stars as almost like the uteruses of the universe. They're spawning chemicals, and all of the big elements that are in us, all the stuff that's in us, the carbon that's in us, is actually material that was made when a star killed itself or existed millions or billions of years ago.
And Janine in Santon, I'm so interested in your question. Janine, hi. Janine, hello. Okay, anyway, Janine, I understand from my from the producers, Chris, that Janine wanted to ask, should she look at her mother to see how she will age?
That's what they say, isn't it? If you want to know what your wife will look like in 30 years' time, look at your mother-in-law. Well, the answer is that obviously your wife is, or husband, is 50% related to each of their parents. So half of the genes in that person come from one parent, and the other half of their genes come from the other parent. And that means that the genes that they share with their mother will include the genes that dictate how they are likely to age, because some people age better than others. because you have genes that enable you to defend yourself against the environment, and some people have more effective repair genes than others. So I think you can argue that you're likely to get a very good insight into what will happen to your family if you look at your immediate relatives as you get older. And this will include how you handle energy and gain weight and that kind of thing, because you've got so many genes in common that there almost certainly will be quite an overlap. In just the same way that you look like them when you're young, you're going to look like them when you're older too, because you'll age the same way.
And then an email, it follows from our conversation in our Healthy Lifestyle feature on Wednesday. We were talking about colic and the stress that parents sometimes experience. And this person wants to follow up and say, please ask the Naked Scientist, is there scientific basis that if a mother is stressed while pregnant, she will give birth to a difficult baby?
Say that again. If a mom is stressed, she'll have a difficult baby
during pregnancy and is a very highly strung person, does that have any impact at all on the baby?
I think it probably will. There was a study that was done about 3 or 4 years ago, and it was published in PNAS, and it was a very elegant study. What this lady did was she got babies that were being born by IVF, in vitro fertilization, using eggs donated by other people. And in some cases, she had eggs that were unrelated, therefore, to the mother. And she was also able to compare those with IVF babies born using eggs from their own mother, if you see what I mean. So some women had used eggs that were donated to them, others used their own eggs to do the IVF. And she then compared the outcomes in their babies according also to whether they had antisocial behaviour or some other problems, and asthma and allergies and things. And she then looked at maternal smoking and other types of behaviours. And she found that maternal stress during pregnancy impacted on the outcomes in terms of antisocial behaviour for both the babies that were born related to their mothers and the babies that were born unrelated to their mothers. And this told her that the stress effect isn't because of genetics, it must be because of the environment in which the child is reared. And so I think it's likely that if you have a baby which is born to a stressed mum, there are going to be consequences. And we know for a fact that if you have a mother who doesn't eat properly when she is pregnant or is starved, this has an effect on not just the child that the mother might be carrying at the time, but also the children's children, in other words, her grandchildren, because if she's carrying a little girl, then the cells that are going to be the eggs in that child are already being formed in the baby inside the pregnant woman. So she's affecting potentially the outcome for her child and her grandchild.
Very interesting. Chris, interesting conversation. We look forward to chatting to you again next week, Friday.
It's been great fun. Thanks, Rudy. Loads and loads of tweets coming in on white dog poo now to @NakedScientist as well. So I'll try and get to as many of those as I can. Thanks, everybody.
Thank you. Bye-bye.
Bye-bye.